All right, we're in section 13.2 where we're going to look at angles and parallel lines. One of the things, or one of the terms that we are going to kind of pay close attention to is the term transversal. Transversal, they say by definition, is a line that intersects two or more lines at different points. So look at this diagram here. We have a transversal, that's the red line in this case, and it intersects at 2 points. It intersects right here and it intersects right here at two different lines. From those two intersections, we have different angle relationships by definition that they kind of correlate with. So the first kind of angle relationships when it's dealing with a transversal is we have corresponding angles. Corresponding angles are two angles that occupy corresponding positions. So here they have some examples that 1 and 5, angle 1 and angle 5 are corresponding angles. The reason for that is dealing with the transversal line and the intersected point. In this case, they're both located in the top left corner of their respected intersections. The other one they have here is 4 and 8. And then to finish up, we have angle 2 because that's top right. The other one with top right would be angle 6. And then finally, we have angle 3 and angle 7 because they're bottom left. So all of those different angle relationships would be represented as corresponding angles. The next one we have our alternating interior angles. Alternating interior angles, it says there are two angles that lie between the two lines on the opposite side of the transversal. So they gave us examples 3 and 6 and 4 and 5. And those are the only uh, two pairings for alternating interior angles. Reason for that is they're in the interior of the transversal. Angles 1 and angles 2, angle 7 and angles 8 are on the outside, so that's the external. We're going to get to that definition in a little bit. And you're dealing with the opposite side of the value. So 3 and 6 are on the opposite sides. 4 and 5 are on the opposite sides as well. To finish this up, we have alternating exterior angles. So like I said, they're on the outside of the transversal. And just like interior angles, they're also opposites. So 1 and 8 are alternating exterior angles, and 2 and 7 are alternating exterior angles. Okay, so in these examples here, they want you to tell whether the angles are corresponding, alternate interior, alternating exterior. So we got 4 and 5. So we have 4 and 5. 4 and 5, well, they're not corresponding because if you look at 4, the corresponding to 4 would be 8. And so since they're both interior and they're opposites of each other, we're going to say this is alternating interior angle. We go to the next one, angle 2 and angle 6, 2 and 6. Looks like it's top right and top right. So they share the same positioning with respect to the intersection. So this is corresponding. And then finally we have angle 1 and angle 8. 1 and 8 All right, they're not in the same positioning when it comes to respect uh, of their spots in the intersection. I got top left, I got bottom right, but since they're both on the outside of the transversal and they are opposites, I'm going to say they're alternating exterior angles. Now, when you have this transversal and the two intersecting lines just so happen to be parallel lines, then the following is true. Okay? The measures of the corresponding angles are the same. The measure of the alternating interior angles are also the same. And the measure of the alternating exterior angles are the same. So, with that being said, I have uh, a transversal here. So the transversal is right here. And my two intersected points here and here, I have two lines that are parallel, which are established by these little arrow marks. Um, so the question that they pose to us is name all the angles that have the same measurement as angle 5. So I got angle 5 is right there. Okay, so going back up to the definition, so looking at it first, everything that is a corresponding angle will be the same. So the corresponding angle to 5 is 1, so that means that angle 1 is going to be the same. I go to the next definition here. It says the measurements of the alternating interior angles are also going to be the same. So I go here, alternating exterior, alternating interior in this case. That means that I have angle 3. Okay, so I have 1, I have 3, and the last value that would be the same angle as angle 5 would be angle 7. Now you could take this two different ways. You could say, okay, it's angle 7 because angles 1 and 7 are alternating exterior angles, and we know that those are going to be the same. We could say, oh, we look at angle 3. Angle 3 and angle 7 are corresponding angles, so we know that they are going to be the same. And stuff that we looked at yesterday, angle 5 and angle 7 are also vertical angles. So since we know that those are vertical angles, uh, we could say that they are also the same angle measurement. All right, now I have here, they want us to name all the angles. Um, name all of the angles with the same measurement as angle 6. So I got angle 6 right here. All right, with the same idea, the corresponding angle to 6 is 2, so angle 2 is going to be the same. I know that angle 4 will be the same because of alternating interior angles. And then to finish up, angle 8 is also going to be the same. And by different definitions, you could say, oh, it's because it corresponds with 4, or it's an alternating exterior angle with 2, or we know that by definition of vertical angles with angle 6, that would make it the same as well. So however you want to place that definition with your own problem, that's up to you. So if we have here, it says if the measurement, this little m means measurement. If the measurement of angle 3 is 62 degrees, find all of the other angle measurements. So that means that 5 is 62 degrees. That means that 1 is 62 degrees. And that means that 7 is 62 degrees. Now, how we determine what angles 6, 2, 4, and 8 are, well, We also have another angle relationship that we can go from yesterday or from 13.1. We know that 5 and 6 are supplementary angles. We also know that 5 and 8 are supplementary angles. We also know that 3 and 4, and there's a variety of other supplementary angles that we can take a look at. But since we know that, supplementary angles, we can take 180 and subtract it by the measurement that we know, which is 62. So 180 minus 62, and that equals 118. So this is going to be 118 degrees. This is going to be 118 degrees. Angle 4, 118 degrees. Angle 8, 118 degrees. Okay. All right. So now it says here we find the measurement of all of the numbered angles. So it looks like we got 1, 2, 3, 4, 5, 6, 7. And they told us that one of these is 80. All right. They have these lines are parallel so that we know that all corresponding angles are the same, alternating interior angles are the same, alternating exterior angles are the same. So going with um, the corresponding angle, which is this case, so this would be 80 degrees. The alternating exterior angle would be 80 degrees. And then the vertical angle would also be 80 degrees. And then the rest of them would just be 180 minus 80, which would be 100 degrees. So 5 would be 100 degrees, 7 would be 100 degrees, 4 would be 100 degrees, and 1 would be 100 degrees. All right. It says we can also look at it backwards, it's saying. So it says if one of the following is true, it says corresponding angles are congruent, alternating exterior angles are congruent, and alternating interior angles are congruent or alternating exterior angles are congruent, then we can say that the lines are parallel. So they're asking here, it says, are these two lines parallel? We can say yes to this statement. The reason for that is because the alternating exterior angles are congruent, which means they're equal. So since that's the case, we can say that line 1 and line 2 are parallel. It says find the value for x that makes line M and line N parallel. So we'll call this line M, we'll call this line N. We want to see if they want to make sure that these are parallel. The only way that we can make sure that these are parallel is we're going to look at these two measurements. These two measurements by relationships are alternating interior angles. Since they're alternating interior angles, we want to make sure that these lines are parallel. These alternating interior angles must be equal to each other. So all we have to do is take 5x plus 2 and set it equal to 102. Subtract 2 from both sides. I got 5x equals 100. And 100 divided by 5, I got x equals 20. So x has to be 20 for line M and line N to be parallel in this transversal. All right, so last step we have here, it says find the measure of the numbered angles. So there's 3 of them. So there's 1, 2, and angle 3. So looking at it here, going from yesterday, I know that angle 1 is going to be 72 degrees. The reason for that is vertical angles. Uh, since I got a transversal here, and line 1 and line 2 are parallel, I know that angles 1 and actually, no, it wouldn't be angle 1. I would say that, let's see. Yeah, I would say that angles 1 and this angle here would be 72 degrees because of alternating interior angles. And this angle here are supplementary. Since they are supplementary, I can take 180 subtracted by 72, which means that angle 2 is 108 degrees. So you had to find some angles that maybe weren't numbered to kind of help you out. All right. Knowing that these are still parallel, you know, this is kind of makes this one kind of easy. This one here is 90 degrees because the corresponding, and 180 minus 90 is still 90 degrees. So angle 1 is 72, angle 2 is 108, and angle 3 is 90 degrees. And that is looking at angles and parallel lines. Hope this helps.